So in this video, I wanted to go over introduction into hypothesis testing for two samples. So I'm going to draw a comparison between hypothesis testing for one sample versus two samples. Um, so in a hypothesis test, if you guys recall, there's three parts. There's the claim, and then we want to test the claim. And once we test the claim, we want to address or make a conclusion. So we want to address the claim. So for this example, for the one sample hypothesis test, we're going to visit the gender selection method example. And if you guys recall, that's the example where a company has developed a drug or some kind of method that would increase the chances of having a girl. So the claim is that the proportion of girls would increase if couples go through the gender selection method. So in symbolic form, P, the proportion of girls, would be greater than 0.5. So here we're assuming that the chances of having a girl is 50% or 0.5. So the claim is P, the population proportion of girls, if they go through the gender selection method, would be greater than 0.5. So the first step in testing the claim, we have to come up with our null and alternative hypothesis. So if you guys recall, the null hypothesis is the hypothesis which states that there's no change or no effect of the gender selection method in this case. So no difference, right? So in this case, the null is P is equal to 0.5. There's no difference. The result of the gender selection method, it's still going to produce a 0.5 proportion for girls. The alternative says that there is a change. So in this case, because the claim is a statement of change, meaning the claim is stating that it's going to be greater than 0.5, we're going to adopt the claim as our alternative. All right, so once we have established our null and our alternative, we're going to take a sample, one sample. That's why it's a one sample hypothesis test. So let's say in this example, 100 couples went through the gender selection method, and the result was out of 100 births, there were 62 girls. We had two methods um, we used to test this hypothesis. The first method was called the p-value method, and the second one was called the critical value method. So I'm not going to go over that, but I will go over briefly the p-value method. So with the p-value method, we obtain the p-value, and if you guys recall, the p-value is the probability of getting this result where you get 62 girls out of 100 births, right? And when to make our conclusion, we compare the p-value with alpha. Alpha is the significance level. So if the p-value is less than alpha, we then reject the null hypothesis. And if the p-value is greater than alpha, we fail to reject the null hypothesis. All right. So there's a lot more to hypothesis for one sample than what I just described, but that's the gist of it. I'm going to draw a comparison to two samples. So with the two sample hypothesis test for the same example, gender selection method, the idea is we're going to have two samples. The first sample is usually what we call the treatment sample, and the second sample is the placebo sample. So the treatment sample is where they actually get the gender selection method in this example, and the placebo group or sample is where they don't get the gender selection method. And so from those two samples, we have to think about what our claim is. So our claim is a comparison between the proportion of those who obtained the gender selection method versus those who were in the placebo group, those who did not obtain the gender selection method. So the idea is the drug is effective, or the gender selection method is effective. So we would say that the claim would be that P sub 1, the proportion of those who receive the gender selection method and having, I'm sorry, the proportion of girls who had couples who their parents went through the gender selection method is greater than the proportion of girls who didn't go through the gender selection method. So that's the claim. From there, we have the null and the alternative. The null, again, says that there's no effect, so the gender selection has no effect. So how we can say that in symbolic form is that P sub 1 is equal to P sub 2. Again, P sub 1 and P sub 2 are the proportion of girls. This is the proportion of girls for the parents who went through the gender selection method. This is the proportion of girls who did not receive the gender selection method. So the alternative in this case is the same as a claim because the claim is a statement of change. So the proportion of girls for those who receive the gender selection method is greater than the proportion of girls for those who did not. So two samples. Let's say that for the first sample, we had 100 parents who went through the gender selection method, 100 births. There were 62 girls. So N sub 1 is the sample size for the first sample. X sub 1 is the number of success for the for the first sample. For the second sample, we have the same or similar notation. So N sub 2 and X sub 2. So 100 parents went through the placebo, were in this placebo group, and there were 52 girls. We also have a p-value method. So in the p-value method, again, we obtain the probability value of getting these or this result. And once we do that, it's very similar to the one sample hypothesis test. If the p-value is less than alpha, we reject the null. If the p-value is greater than alpha, then we fail to reject the null. All right, so very similar. If you understand one sample hypothesis test, transitioning to two samples shouldn't be that difficult. The biggest difference, again, is we have two samples and we're comparing those two samples. All right, so in addition to the p-value method, there is another test that you will need to know, and that is the confidence interval method. So for the two sample hypothesis test, the confidence interval method, what we get is we obtain an interval estimate for the difference between the two population proportions, so P sub 1 minus P sub 2. So before we get to the conclusion, here's a little side note for the confidence interval method. There's three outcomes. So if three things to consider. If P sub 1 minus P sub 2 is equal to 0, then we know that P sub 1 is equal to P sub 2, right? P sub 1 minus P sub 2 equals 0, then P sub 1 equals P sub 2. That's how you get 0, right? You get two things which are equal, you subtract them, you get 0. If this is the case, then there's no difference between the two proportions. The second case is if P sub 1 is minus P sub 2 is greater than 0, then it must mean that P sub 1 is greater than P sub 2. So in this case, if you look at this, P sub 1 minus P sub 2 greater than 0, that indicates that this is going to result in a positive value. That can only happen if P sub 1 is greater than P sub 2. If this is the case, then there is a difference between the two proportions, meaning the P sub 1 is greater than P sub 2. So in our example of gender selection method, what that means is the proportion of girls their parents having gone through the gender selection method is greater than the proportion of girls for those who didn't. The third outcome from the confidence interval method, the third thing that we can get is if the P sub 1 minus P sub 2 is less than 0, then P sub 1 is less than P sub 2. And in that case, there's also a difference between the two proportions. So if P sub 1 is greater than P sub 2, or if P sub 1 is less than P sub 2, if that's what the results we obtain, if we obtain that result, then there's a difference between the two proportions. If P sub 1 is equal to P sub 2, then there's no difference between the two proportions. For the conclusion, if there is a significant this either one of these cases, then we reject the null. If the p-value, this should have been, if there is no significant difference, then we fail to reject the null. All right, so that's just an overview of hypothesis testing for two samples. In other videos, I'm going to work out some problems. So if you have any questions, let me know.